I'll start with the basic simulation. So as I said, there are many tools available in the industry for CAE. There are some tools specifically used for research purpose. Some are used for particularly design purpose. Because what is the difference with research kind of things is it needs extensive control over users, so that where user can have maximum interaction kind of things. As a designer, it may not be needed that much interface or something like that. So that designer wants quick results in short span of time because he wants to analyze his design in a quick manner. So in that case, this tools is I think better. As I seeing this presentation in this slide, you can see that ANSYS APDL, or you can call it as ANSYS Classic, and ANSYS Workbench. ANSYS APDL or ANSYS Classic is somewhat used by the researchers so that where they can have mesh controls or element controls or solver controls. And compared to ANSYS Workbench, it is not so user-friendly. ANSYS Workbench is user-friendly, easily can be learned, can be linked. And in the coming slides, you can see that one. And one more thing about ANSYS Workbench is it is very well interface with your geometric modeling capacities. So it is the greatest advantage. Okay, and ANSYS, as I said, it is used for specifically for designing purpose, designers. Fine, hope you understood the basic things in this slide. So meanwhile, I want to stress more on tool-based to domain knowledges. What I mean is, before going to any simulation packages, not only ANSYS or anything, we need to understand the physics, or we need to make our physics domains very strong. Like basic, what is structural, how can we do that one, what are the things needs to be done, everything. So we'll move to next slide. I will take in the almost in the last slide some of the things regarding this one. So basically there are many licenses available in ANSYS Workbench. ANSYS Design Space is a basic license available, which includes linear, static kind of things, modal, buckling, also thermal, some of the things. And higher ups like ANSYS Professional, ANSYS Structural, ANSYS Mechanical, which includes the previous things, but extra things like harmonic thermal analysis kind of things. And one more thing is available is student license or academic license, which have the node limitations. I think is 1 million D of something. It is only for teaching and academic purpose. I'll move to, I think I'll take the question and answer in the last, whenever something is coming up. So go through that ANSYS different workbench modules. We have structures. Under the structures, you can see many of the things here. And under fluid, you have many of the things. And ANSYS Workbench is not only meant for mechanical, it can be used for people like civil, structural, electrical, electronics, anybody who works with the physics applications. Some of the modules you can see that heat transfer, composite material structure, solver capabilities. These are all very useful and handy. And it is continued with the next slide with the system modeling, multiphysics applications, software embedded, geometric design tool, optical. These are all some of the new addition, like material, or it is almost maximum materials are integrated. I think as far as I know, material, web material, some sites directly linked, they can import the data from there and they can integrate with the material to here and they can use directly. So this is somewhat GUI looks like. You can see that in the left side, you can have analysis systems, different systems. You can directly pick and drop, pick and place, and you can connect different levels like meshing to next level. You can have linkage mechanism where you can have connections. What are the physics you want? Okay. So some of the things you can understand in detail when I'm going in deep. Just I am showing the things which is available right now. So any markings is I am not getting why this marking is coming.
So can you just stop your screen and share again, sir, so that the marking can be removed? So I can
Oh,
just continue.
it's okay, fine.
And just give me 1 minute. Participants, please don't scribble on the screen. It will be disturbing the session. If you are not interested, we never force you to stay. You can just move out. Yeah, so
So
you can just continue, sir.
yeah, it is not a compulsory because it is a nice session because you have a long journey if you want to take up. We are not taking as a workbench only. It is like the physics behind, if you understand the maximum tool is not a matter. You need to have that attitude because it is the basic ethics are there. You need to understand that one. Okay, we'll move on to next thing. So coming back to slides, there are many industries. Usually education department is extensively using this one because from long term they are associated with the education sector. They are continually improving their software, also application in different modules. As far as I know, I started working with 5.4 ANSYS. That's the base version, which is commercially, I think, released. Till now, they improved a lot from 5.4 version to here. Slowly, it is moved into machineries, aviation, aerospace, automotive, architectural planning, and computer software. So there is a new trend is coming up. Even aerospace, which I used to work, we are extensively using for like different commercial programs. So these are all many things. Even there are very good domain in healthcare nowadays is coming up. Simulation of many things, flow kind of things, blood flow in the heart related issues, where it's a blockage kind of things. There is some simulation, even bones kind of things. It is a very much a domain which is coming up. So coming up to this stage, there are a lot of things to talk. There is a previous part is about the ANSYS licenses and different cases that will be one of the things, softwares, hardwares, and other things. Because as an engineer, it is nothing to much worry about the that part because we need to concentrate more on science aspects. So initially, as I said, if you want to take a analysis, there is nothing like initially put into some analysis packages like Workbench and giving some boundary condition, solving is not a prime importance. What is important is first you need to understand the model about which part needs analysis, whether really it needs analysis, the first part. Second part, if it is so, what are the intricacies, curves, how need to mesh, discretization. Already I think, so first and foremost thing is why I need to do analysis for the above mentioned components or any components. First of all, we need to see whether really needed that analysis. Why I'm telling this question is, so every product, everything based on or related to finance or money, we need to choose things which is critical, first of all, because everything add up to cost to the product. Keeping that mind, we need to start working. So there are many things. Which component needs to be taken for analysis? The answer, as already told, which is critical in the path of whole system. We need to analyze throughout the system, component by component, because it is not like you have taken one component and where the load coming from that. It has to come from something behind that or which is connected to, or whether it is in load path. We call it as a load path. Since load transfer happening one stage to another stage, we need to analyze the things based on that inputs. For example, central line actuators. In a commercial flight, if your actuator is situated on, like, in the wings, like it may be elevator, rudder, inboard aileron, outboard aileron, what all the things. There's some load has to come on it. From where we'll get that one? There will be load data, sensors, which gauges from the surface of the wings coming from the atmosphere. There are many things which can leads to this one. So because of short sessions, I may not be able to the load path and load calculation. These are all things. But when you understand that one, that is the starting point of your analysis. The simulation part and your software comes somewhere in between. It is not the major factor. First, you should understand all the calculations, where it is coming, what load is coming, and where it is fixing, how it is fixing. Nut and bolt arrangement, kick link mechanism, or lug is directly connecting, how it is connected, how degrees of freedom it has, wherever it is free to move. These are all factors decide your analysis. If you make a mistake in the first stage, after running the things, the result will be something different, which is not acceptable. And by the time you will be spending a lot of time, your energy, also machine cost, or even your electricity running, everything counts. Before analyzing or giving solution, the things, you make sure that first of all, the physics, your calculation on force balancing calculations, and everything. Once you've done that one, after when you're doing the meshing part, it is also as good as first stage. Whenever you make a meshing in a proper manner, result will be okay. Again, there will be issues with the point loads because of wrong meshing, wrong methodology, which leads to wrong results. Again, you will have the lose the time, energy of running. So that's why I'm asking all the people, be very careful in the first stages only. Once it is okay, then your results can be predicted and for further discussions. For example, I said I got 145 KSI for 15.5 pH. 15.5 pH, I got 145 KSI around. What is next? So I need to think whether this result passing, what outcome is coming, is I can use for next stages, how I calculate for further calculations, how I use this one. These are all things comes into post-processing kind of things. I think everyone is clear about this one. I can discuss further on this one also. So that's what outcome. And once you got the outcome, further calculation can be done. Next, what needs to be done of that value? Because the lab test or qualification test there is no alternative for that. Physical test will be there in any cases, and we need to match our simulation result to that one with some percentages or some factors we need to add, material factors, notch factors, geometrical factors. We need to add many factors and we need to come up with very close relation to actual testing. Once you establish the linkage between the lab test and your simulation with agreeable margins, then you can proceed with the different iteration for design optimization or any other mechanism you want to follow, you can do that one. These are all the basic things needs to be done in simulation. And one thing I want to tell you, this is not the case of urgency because analysis needs very patience, need to observe the minute things, observe the geometries, where is the things which needs to be done, which part needs to be eliminated, and we need to keep the model as simple as possible. And we can build on that one. Okay. So I'll be moving to the next slide. Many people will ask, the student will ask, if I do this one, can I get a job? What kind of job I can get? See, I can make it clear that one, like this is usually needs strong engineering fundamentals to justify your answers, because there is nothing like you can gain knowledge without doing. Everything you need to do, you need to fail, you need to get the results. Next time improving that model, because at a time, first attempt only, getting the right result may not be possible many a times. As I said, there is a your calculation part has to be done correctly, machine part has to be done correctly, loading part has to be done correctly, force balancing you need to check, you need to have convergence, stress converge, or what are the convergence you can do that. After that, you need to come into some stages. As a beginner, the job roles will be maximum people will plays a very important role of machine, that is discretization stages, pre-processing stages, where students or newcomers or maximum people be involved, trained or anything, because they have to be make the model, mathematical model perfect. That's the stage where it takes maximum time. As you go up to the ladder of your career, you can make yourself in the stage where you can make some decision based on the results. Fine. So as I said, now stress is coming 155 KSI. What decision you have to take? Whether you go for change of geometry, change of material, change of mechanism, anything that can be taken up in the next level of experienced people. There is nothing like you can take now also you can take if you are very good at engineering domains, but it comes with experience, I feel, because as I said in the beginning, everything related to cost. If you want to change a geometry, what is the process needs to be changed in manufacturing? Is it feasible? Then if it is not feasible, if you have sufficient tool to manufacture, or you need to have different tools to manufacture for your design, how much costs. That's all matters in when you are going for these kind of things. Fine. Next level, as I said, all the things will definitely going to for charges for products, it will increases. So you need to be very careful while designing also. You need to be in decision making level. You need to have very strong knowledge on manufacturing process and other even financial aspects. How much going to cost, how much if I change this one, what all the things can be done, everything. So moving up to still next level, it has to be system level. If you change small component in one chain, what is going to affect in whole system? That's the most important and critical part. And in many cases, system level people will know that if you change something or some performance changed as a whole system, how it's going to change. They'll be having the view on this one. And slowly when you grow up to that level, you will be coming up all the issues of system levels. Okay. So these are all things. There are different job roles you can enter into that one. It's not only tool based, you should have knowledge based. Once you thorough with this knowledge, finite element, I hope you are as an engineering student, all the other things also coming, you may be knowing like finite element, finite volume, finite difference methods, H method, P method. Hope you learned that one. Okay. So when to use that one and what are the advantages? So these are all things can be discussed in the later also. So these are all things I want to highlight in the beginning because very short duration is a very vast domain, like choosing the elements to solving the problem.